Hello sir, we have discussed turning on method of SCR. Now this video we are going to see commutation of SCR. Commutation methods are rotating but turning off an SCR. Now what are the different type of method or different type of circuit can use to turn off and SCR or SCR? It can be turned off as it is on their way joining to seen in this video. So basically first of all we have discussed turn off process of SCR means commutation. The process of turning off a computing is known as commutation. Depending on the nature of source AC or DC, the commutation can be two types. First one is natural commutation and another one is forced commutation. Natural commutation is also called line commutation. In natural commutation we give AC supply at input side, or AC supply is responsible for natural commutation. This is the diagram of natural commutation. We are using diode, source and resistance. Sinusoidal waveform of natural commutation. Half wave cycle of natural commutation is rectified output of waveform. This is the input waveform of sinusoidal. This is the current waveform of output current waveform. This is a voltage output waveform. Both are current waveform output and voltage waveform is same. Latching current is an important parameter while designing turning off SCR, but the holding current is an important parameter when you are understanding the turning off process of SCR. Now let we show here we going natural commutation. Natural commutation I have shown in simple diagram. So this is my SCR load connected is resistive load and source is applies AC source. Whatever there is a AC source connected to SCR can commutated naturally. Now comes as AC source. I have this is my input voltage supply, this is my AC source given to circuit, and the load resistance is our resistive load. A resistive load is in the circuit flow through the SCR current flowing through resistor. Now let's see, this is my input voltage which is given to circuit, that is Vm sin omega t, and so amplitude will be positive Vm. Amplitude of this negative cycle will be negative minus Vm. Here I have shown the output voltage and the output current flowing through the circuit, that is I0, and the dotted line is I0 and V0 is V0, nothing but the voltage across the resistive load. Now the positive cycle, that is from 0 to pi when is positive half cycle. My SCR is this terminal is anode and this terminal is cathode. This is terminal, gate terminal. Now here I have gate terminal is open. At this point my anode to cathode voltage will be positive. Advantage of natural commutation: it does not require external commutation components. It is reliable and it is also simple for designing. As we discussed another type of personal communication, when SCR is operated on DC supply, it is not turned off naturally. The SCR is turned off by some external circuit is called as forced commutation. This is a external circuit is called as commutation circuit. There are also five types of forced commutation. These are class A, class B, class C, class D, class E. In class A, self-commutated or resonating commutation. In class B, self-commutated or current commutation. In class C, C or LC switched by another load carrying SCR. In class D, C or LC switched by an auxiliary SCRs. In class E, an external pulse source for commutation. In forced commutation, in case of DC circuit, there is no natural current 0 to turn off the SCR. In such circuit, forward current must be forced to 0 with an external circuit known as commutating circuit to commutate the SCR, hence the name forced commutation. This commutating circuit consists of the components like inductor and capacitor, and they are called commutating components. These commutating components causes the apply the reverse voltage across SCR that immediately bring the current in SCR to 0. Depending on the process for achieving 0 current in the SCR and the arrangement of commutating component, forced commutation is classified into different types. There are class A, class B, class C, class D, and class E. As we see above the discussion, how it works. An external circuit called a commutating circuit applies a reverse voltage across the SCR. This reverse voltage reduces the anode current below the holding current values. The current in the SCR is immediately brought to 0. Applications of forced commutation. Forced commutation is used in inverters, choppers, and other DC powered devices. The difference between natural commutation and forced commutation. Natural commutation, first point is natural commutation is used as AC voltage at the input. In forced commutation uses DC voltage at the input. Second, it does not use external components in natural commutation. In forced commutation, it uses external components. In natural commutation, this kind of commutation is used in AC voltage controller and the controlled rectifiers. In forced commutation, it is used in inverters and choppers. In natural commutation, SCR or thyristor will be deactivated because of negative supply voltage. In forced commutation, SCR or thyristor will be deactive because of the both voltage and current are positive. During the commutation, there is no loss of power in natural commutation. During the commutation of power, loss occurs in forced commutation. Natural commutation have no cost. In forced commutation have significant cost for forcefully commutation or forcefully of the SCR. Thank you.